Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Syauqi bin Roslan. So I will present about the beam that I have analysed, which is beam 3BC for simply supported beam and beam 1AC for continuous beam. So for the simply supported beam, the design load calculate is 31.37 kN per meter, which is load from slab and on beam. Then based on the shear force diagram and bending moment diagram, the maximum shear force is 47.06 kN and the maximum bending moment is 35.29 kN meter. Next, for part main reinforcement, because this beam located on the ground floor, we consider this beam as rectangular beam. And then since the value of K balance is more than K, the compression reinforcement is not required. Then after we calculate, the value of area of tension reinforcement is 401.68 millimeter square. And then based on standard, we choose 4 bar H12 as area proof, where the value is 452 millimeter square. Then for shear reinforcement part, we got the shear minimum of link is 75.33 kN, and for the deflection, we got the actual deflection is 12.55, which is less than from allowable deflection. And lastly, for cracking, we got the steel stress is 294.34 Newton per millimeter square, and the bar spacing is 64 millimeter, which is less than the maximum allowable bar spacing.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Haris bin Yasin. Metric number is TF210014. Today I want to present about analysis of a simply supported beam in this project. The beam selected in the roof plan is beam 1A/A to B. After calculation was carried out, design action at the beam is 33.36 kN and the maximum bending moment is 37.42 kN. Next, the area of tension reinforcement for this beam is 360 mm² and we use grade 5H10 for the area provided is 393 mm². After that, for this beam, we use spacing H6 175 and in the deflection part, actual span effective depth is 11.93 and this value is passed because it's less than I over the allowable. Lastly, in the cracking part, steel stress for this beam is 318.2 Newton millimeter square and the value of bar spacing is 64 mm and this value is less than maximum allowable bar spacing, which is 100 mm and the value is passed.
Simply supported beam, I have choose the simply supported beam from the roof plan, which is the 3B until C, this span. So this is the shear force diagram and the bending moment diagram of the beam 3BC. So the maximum shear force is 453.16 kN, while the maximum bending moment is 39.87 kN meter. So for the simply supported beam 3BC, the main reinforcement that will be used is the area of the main reinforcement is 566 mm², because the area of the tension steel is 553.63. We will use the area slightly higher than this from the table, so we will use 5 bar of H12, while the shear link, because of the spacing, is greater than 0.5D. We will take 179 as the indicator to be referred in the table, so we use H8 175. Next, the deflection. The ID allowable is greater than ID actual, so it is okay. The allowable is 17.55 while the ID actual is 12.55. Lastly, for the cracking, the S is 76.5, which is lower than the maximum allowable bar spacing, which is 100 mm, so it is okay. Next, this is the detailing of the simply supported beam 3BC. The shear is H8 170 and main reinforcement is 5 bar of H12.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad bin Nizam, number metric BF 310056. Today I will explain about analysis simply supported beam at 2A, A to A prime. Firstly, I analysis the design action at beam 2A until A prime. Shear force is 28.95 and the bending moment is 28.95. After get the design action beam, the area tension reinforcement is 279 mm and the grade is provided is simply supported at beam is 6H8 as provided is 302 mm. The spacing for the beam is 479 mm and the maximum of spacing is 189 mm and the grade is H6 175. To continue the analysis, calculate the allowable span active depth and actual span effective depth. The actual for the beam is 8 less than the allowable span is 27. Is that mean pass? For calculate cracking, I will determine the cracking. Lastly, the cracking part is the beam. The value of steel is 298.9 Newton millimeter. After get the steel stress, the value of bar spacing is 64 millimeter and its value is less than max allowable spar, which is 100, and its value is pass.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Hakimi bin Ismail and I will tell you about the simply supported beam that I have analysis. So the beam that I have analysis is 1A AB. So the total design action for this beam, the value of the GK is 20.99 kN per meter. The value of QK is 2.7 kN per meter, and the design action that I get is 32.39 kN per meter. Next is the shear force for this beam is 48.59 kN. And the bending moment value is 36.44 kN. Next is the area of tension reinforcement. I get the value is 351.9 mm. So by referring the standard, I use the grade of 3H8 with the AS provided is 151 mm square. Next is for the spacing, I use the H6 175. And next is the actual span effective depth. I get the value is 11.93, that less than the value of allowable, which is 17.43, that can be considered okay and pass. Next is for the cracking. The value of steel stress that I have obtained is 292.663 Newton per millimeter square. And for the bar spacing, the value that I get is 64 and less than the value of allowable bar spacing, which is 111 mm, that can be considered and pass.
So I will continue our presentation about the continuous beam that I have analysed, which is 1AC on the first floor. So the design load calculate is 29.59 kN per meter, which is load from slab and on beam. And then based on the shear force diagram and bending moment diagram, the maximum shear force is 55.88 kN on support B, and the maximum bending moment is 19.51 kN on span A to B. Next, for part main reinforcement, because this beam located on first floor, so we consider this beam as flange beam. And so we got the same value of effective depth for span AB and span BC, which is 251.5 mm. Then after we calculate, the value of area of tension reinforcement for span AB and BC is 180.86 millimeter square. And then we refer to standard. We choose 4 bar H8 as area proof, where the value is 201 millimeter square. Then for support B, we got the area of tension reinforcement is 327.19 millimeter square. Then we choose the value of area proof is 339 millimeter square, which is 3 bar H12. And then for shear reinforcement, we got the shear minimum of links is 79.27 kN, and the longitudinal shear stress is 0.377 millimeter. And next, for the deflection, we got the actual deflection is 11.93, which is less than from allowable deflection. And lastly, for cracking, we got the steel stress is 295 Newton per millimeter square, and the bar spacing is 64 millimeter, which is less than the maximum allowable bar spacing. So I think that's all about summary of beam 1 AC on first floor for continuous beam. So that's all.
I want to continue to present about analysis of a continuous beam in this project. The beam selected in the ground plan is beam 1/A to C. After calculation was carried out, the design action at this beam is 30.19 kN per meter. Next, this analysis of a continuous beam that has three cases is used to find the maximum shear force and bending moment in all span of the beam, and the maximum value of shear force and bending moment at span A to B is 34.62 kN and 19.91 kN. Next, the value of shear force and bending moment at span B to C is 56.61 kN and 19.76 kN. Besides, the area of tension reinforcement for span A to C is 177.6 mm square, and we use grade 4H8 for the area provided 201 mm square. Next, the value of tension steel at support B is 340.84 mm square, and we use grade 7H8 for the area provided 352 mm square. After that, for this beam we use spacing H6 175, and in the deflection part actual span effective depth is 11.93, and this value is passed because it's less than allowable span effective depth, which is 50.29. Lastly, in the cracking part, steel stress for this beam is 294.48 Newton per millimeter square, and the value of bar spacing is 64 millimeter, and this value is less than maximum allowable bar spacing, which is 150 millimeter, and the value is passed. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Faris Mifzal bin Abdul Halim, DF210073, and today I will explain about the continuous beam that I have selected from our house plan, which is 4A until C. So this is the beam that I have selected. Next, this is the shear force diagram and the bending moment diagram of the beam 4AC. The maximum bending moment is on the span AB, which is 48.08, while the maximum bending moment on the support is 53.62. For this continuous beam, we use 6 steel bar from H10, which is the area is 471 mm squared as the AS provided, as the area of tension reinforcement is 448.63, and it is in the range of the AS minimum and AS max, which is 85.33 and 2700 mm square. On the support B, we On the support B, the AS provided is 466 mm, the steel bar area. Next, for the shear link, the spacing that we get for the shear link is 196.15 mm, which is larger than 0.75D, which is equal to 188.63 mm. So we will use H6 175 mm as the shear link. Next, for the deflection, the value of the allowable is greater than the actual. The allowable is 17.62 while the actual is 11.93, so the deflection is within the range and it is okay. Next, for the cracking is 64 mm, which is lower than the maximum allowable bar spacing, which is 100 mm. So it is considered okay. Next, this is the detailing of the beam for AC. So this is from span AB and this is for span B to C. The length is the same. So for the shear link, we will use H6 175 and for main reinforcement 6H10. It is the same for the both span. That's all from me. Thank you.
Next, for example about analyze continuous beam. At AAC, first analyze the design Asian beam at AAC. I will separate two span because it's not same length, such as span A1 and A1 until C. After that, there are three cases we must calculate. First, for example, all span max load, maximum load, and maximum load and minimum load, and last case is minimum load and maximum load. After I analyze, I get 3 shear force and 3 bending moment for the calculation. In that situation, I take the maximum value for each value. Shear force is 23.66, 29.81, 71.65, 50.3, and the bending moment is 10.06, 37.53, and 36.73. After I get the design action at beam, the area of tension reinforcement is 92.29 mm square. The grade is provided for continuous at the beam is 2H8 as Prof is 101 mm square. The area of tension steel 376.97 mm square. The grade is provided for continuous beam is 5H as Prof is 393 mm square. The spacing for the beam is 195 mm is more than 0.7D and the grade is H6 175. The continuous and to continue the analyze, calculate deflection, the allowed span depth and actual span depth. The actual for this beam is 13.9, less than allowed span is 113 and 0.8 is that mean pass. For calculate cracking, I will find the limit cracking width. The lastly is cracking part is beam. The value steel stress is 290. After get the steel stress, the value of bar spacing is 94 mm and its value is less than max allowable bar spacing, which is 100 mm, and the value is pass. Is safe for the building for requirement. That's all from me. Thank you.
Okay, next I will continue with the continuous beam. So the continuous beam that I analysis is beam 2AC. The total design action for this beam, the value of the GK is 35.6 kN per meter and the value of the QK is 6.669 kN per meter. So the design action for this beam is 58.1 kN per meter. For this beam, there are 3 cases that used to obtain the maximum shear force and the maximum bending moments. At the support A, the value of maximum shear force is 73.6. At the support B, the value is 108.93, and at the support C, the value is 67.24. Next is for the value of maximum bending moment. At support A, the value is 49.57. At support B, the value is 65.37. And at the support C, the value is 38.78. Next is for the span A to C. The area of tension reinforcement, the value that I get is 461.8 mm square. So by referring the standard, I use the grade CH10 with the AS provided is 471 mm square. After that, at the support B, the area of tension steel, the value that I get is 711.33 mm. So the grade used 7H12 with the AS provided is 792 mm. Okay, next is the spacing is H175. After that, the actual span effective depth, the value that I get is 11.93, which is less than value of allowable, which is 17.11. That can be considered okay and pass. Okay, next is for the cracking. The steel stress, the value of the steel stress that I obtained is 281.45 Newton per millimeter square. For the bar spacing, the value that I get is 64.0. That is less than the value of allowable, which is 150 millimeter. So this can be considered okay and pass. So that's all from me. Thank you.